Alright, today we're going to proceed to do problem number 2 of homework number 3. Now, there's a lot of initial givens to this problem before we even proceed to dig into it, so let's get started. First and foremost, we have x as a random variable with a probability density function defined by this little f of x right here, which is basically e to the negative x plus 1 times the unit function of x plus 1. Now, I draw out this function right over here, as you can see. Basically, given the unit function, we can see how it only begins at negative 1, because values above negative 1 will equal to 1, below that is 0. So all these values are going to be 0. The rest is defined by this e to the negative of this summation right here, which corresponds to this curve right here. All right, starts right here at where y equals 1, and then slowly plateaus toward the x-axis. Before we even proceed, it's important that maybe we try to derive the big f of x of t from this, even though it's not directly given, which we do right here, plus we draw the function. If we do the arithmetic, which is basically take the integral of our little f, we find that the big f of x corresponds to 1 minus e to the negative of x plus 1 times the unit function of x plus 1. Again, if we look at the graph, corresponds to 0 values below negative 1. And this right here corresponds to this curve that slowly asymptotes where y is equal to 1. All right? So those are some givens we have. Now, we define the y specifically by a function g of x. All right? And g of x is defined by the absolute value of x between negative 1 and 1, not inclusive. It is 0 otherwise. And we actually drew out that function right here, so you can see it. It's 0 above 1, 0 below negative 1. Otherwise, it corresponds to these linear lines right here. All right? So that's what we have to begin with. This problem actually has 2 parts, which asks us to find and draw little f in respect to y, and then find and draw big F as respect to y. All right? So let's get started with little f first and foremost. Now, finding of little f of y has 2 parts. We have to find the value of little f of y when y is equal to 0, because this point right here. And then we can use the fundamental theorem to find little f of y between 0 and 1, not inclusive. It's going to have 2 parts, which we'll get into in a minute. So, in order to find little f of y specifically at 0, we use big F of y at 0. And what we're trying to do is figure out what the probability would be at that specific point. Now, we know that basically y is going to equal 0 below the negative 1 and above 1. All right? Which we wrote out right here. That's going to correspond to a big F of x at negative 1, so all the values below here for probability, and then all the values above here for a probability, which corresponds to 1 minus f of x at 1. So basically everything minus this portion. All right? If we do the corresponding arithmetic, plug and chug, basically the equation that it gave right over here. We plug in the numbers accordingly, the equations. All right? As you can see, it works out to be e to the negative 2. Now, that's what the big f of y is equal to at y equals 0. The corresponding little f of y at y equals 0 would thus be e to the negative 2 times the Dirac at y, or the delta function. So that's our value specifically of little f of y where y is equal to 0. Now how about the rest of the function, where basically little f of y is between 0 and 1? Well, we can use the fundamental theorem in that case. And we can see how we can divide our equation into two parts, between -1 and 0, and 0 and -1. Because basically every y value is going to have a corresponding x value that's either on one side or the other. It's going to have two x values. So we have to break it up like this. So we're going to use little f of x, which we have, from -0 to 1. And we're going to do it over the derivative of g in the same range. And we do this right here. And if we work out the arithmetic accordingly, and we plug in the right numbers, the negative y's right here, we can see how the equation reduces down to e to the y minus 1 plus e to the negative y minus 1, which if you actually work out is equal to e to the negative 1 times the sum of e to the y plus e to the negative y. Now we should note, as we said, little f of y above 1, and where y is below -1 is going to be equal to 0. So from this we can actually figure out our total equation for little f of y for y. It's basically going to be equal to e to the -2 times the Dirac formula at y equals 0. It's going to be equal to the equation we calculated using the fundamental theorem right here, from 0 to 1 and y, not inclusive, and it's going to be equal to 0 everywhere else. And if we look at the corresponding graph to this, we can see as such. We can see at 0, this little Dirac formula equal e -2. Excuse me. We can see how it's 0 below 0, below right here, 0, and above 1 on the y-axis. And we can see how this curve corresponds to this equation right here. All right, where this point right here is equal to 1 plus e to the -2. And that's the graph of our little f of y. Now, if we move on to calculate, find, and draw the big F of y, what we could basically do is just basically find the integral of our little f of y and work from there. So that's how we do this portion of the problem. We can see right here we're going from -infinity to y, which we can then break down from -infinity to 0. Now this we already calculated. It's going to correspond to that e to the -2. Plus this integral of f of y from little above 0 to y. So we take this, e to the -2, we got that. We find the integral of our small f of y, which corresponds to basically breaking up this equation right here. We can take out the e to the -1. Then we can find, can basically break down the integral into e to the z and negative e to the, to e to the z and e to the negative z. Sorry about that. And then we calculate each part. We do the basic arithmetic, cancel out ones. Comes out e to the -2 plus e to the -1 times the actual difference of e to the y minus e to the -y. Again, we know big F of y at y is going to be equal to 1 when y is greater than 1. And when we end up as an equation for big F of y is e to the -2 plus e to the -1, basically what we described up here, times the difference of e to the y minus e to the -y. And the graph corresponds to this right here. Basically, we have a big F of y equal to 0 up to y equals 0. Then we have this jump up to e to the -2, corresponding to this. Then this right here corresponds to this curve. This goes up to 1, up till 1, And then, as described up here, we have a probability of 1 proceeding forward. And that's the end of problem number 2.